Anyway, difference of squares is the most common of the three formulas. And like I said, I don't know what questions it asks you on those knowledge checks. What I do know is on the final exam, I know what it asks you there. And there are several difference of squares on the final exam. Okay, let's do another example. So, square root of 9 is 3, square root of x squared is x, square root of 25 is 5. I'm trying to make this one. Anyway, I was able to take the square root of everything, and so now plus minus 4yz and 7x squared. Okay, so this has square roots. Factor. Okay. Sometimes these say factor using the difference of squares formula. Sometimes they just say factor. So let's factor this. But two things I need to think about. One, just because it doesn't fit the formula right now doesn't mean it doesn't factor. I could Well, then the binomial that's left, there's a minus sign, and square root of 9 is 3, square root of x squared is x, square root of 4 is 2. So put your GCF out front, and then do your plus and your minus, and copy paste. The second thing is a special case trinomial, but I'll get to that in a bit. I want to teach you the third thing that you need to know for this week, and that's how to solve quadratics. And that sounds horrible. I'm not very creative, so x squared minus 25. At the very moment, this is not an equation. This is an expression. There's no equal sign, okay? But as soon as you put equals 0 right here, we have an equation, and equations can be solved. They have one answer, but quadratics are special because they have two answers. The reason I know they have two answers is because their power is 2. Whatever your highest power in an equation is, that's how many answers you'll have, okay? Quadratic highest power is 2. That's not a very like educated definition, but that's exactly the definition. When your equation or expression, when the high there is a theorem. I don't necessarily need you to memorize this at all, but I just want to tell if you had to type that in, it would probably be like type it into this box. You could just type -5, 5 or 5, -5. The order doesn't matter. So what if you have is you do want to factor there's a GCF of 2, you would be left with x squared plus 5x plus 6. Things that multiply to give me 6, but add to give me 5 are the numbers 2 and 3. And now you said all I hope that it's going to work out. Again, I'm not good at making up problems, so we're going to see. The directions are solved. So I'm just getting a little bit more advanced with this, okay? That formula that I gave you earlier, it's got a name. It's like something like 0 product property. And I guess I'm telling you the name because it's got to be set equal to 0 for it to work. And so right this second, I can't use the 0 product property. It can't be set equal to 18. But I can fix this. I can subtract 18 from both sides. And I did put it in the order. So now I can just try to factor the trinomial. Things that multiply to give me negative 18, but yet they add to give me negative 7, 2, and negative 9. So x plus 2 equals 0, x minus 9 equals 0. Are we okay with the zero product property? Now the factoring, you still may need some work on that, and I'm gonna show you some formulas too. But it's the solving the quadratics using this zero product property again, it literally adds one step to your factoring problems. One step at the very end. Okay. Let's continue on with the three binomial formulas. I'll go ahead and tell you the next two at the same time. Their names, difference, of cubes, and sum of cubes. So a difference of cubes. It starts off with a cube and a cube, two cubes that are subtracted. That's the way it starts off. And a sum of cubes is two cubes that are added. As I write the formula down, I'm gonna work a difference of cubes problem. Call this 2.1. The way the formula goes, you find out what those cube roots are, and for the difference of cubes, you subtract. For the sum of cubes, you add them. And then there's some more in just a bit that I want to put with this. But you find the cube roots, and for the difference of cubes, you subtract the cube roots. For the sum of the cubes, you add the cube roots. So what does that mean? And by the way, this is, I guess we'll call this 3.1 because this is a sum of cubes. So the cube root of x cubed is x. The cube root of 8 is 2. Now, how did you find that out? Well, remember when I said for the square root, you divide the power by 2? For a cubed root, you divide the power by 3. So 3 divided by 3, that's the first power, okay? But now, 8, how do you take the cube root of 8? There's a key in your calculator that'll do the cube root for you, so you can type it in that way. Or you could just do like I I guess, a process of elimination. And in your calculator, do like 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3. Whichever, and keep going until you get this number right here. 2 times 2 times 2 is 8. So the cube root of 8 is 2. Once I know those cube roots, then and again, this is a sum of cubes, I write them down. I add them together. This is what I've done so far. I've added them together. And there's about to be a trinomial that comes after this, okay? And I'm going to tell you that right here. So once you've taken the roots, you're going to then use that root and you're going to square it. You're going to multiply them together and you're going to square the other root. And you're done. Now, the two formulas, I wrote the difference of cubes wrong. It's minus plus plus. The two formulas are the exact same. The only thing different is the signs. But notice your A, your B, your A squared, your AB, your B squared all goes in that same order. For the difference of cubes, the signs goes minus plus plus. For the sum of cubes, the signs are plus, minus, plus. So since this is a sum of cubes, I can go ahead and tell you my signs are plus and then minus plus. Now, it's going to be good for you to memorize these two formulas right here, but I don't know that it's going to be like the end of the world if you don't have them memorized by like when we take the test Monday. Okay, I'll probably go over this again when we review for the final exam and suggest that you like memorize it then. But as long as you are familiar with it, even if you get the answer wrong on that scheduled knowledge check, it's gonna like respect that maybe you took the root the correct way and maybe you did everything right but had a wrong sign. It's gonna like, when you do that knowledge check, it's not just right or wrong. It grades, how wrong you might have been. Okay, so you took your roots, and what the A squared, the AB, and the B squared mean, your A and your B were the roots that we found. That's the cube root of x, the cube root of 8. So right here, I'm just going to square the first one that I found, which was x. So x squared, you could also think about it this way. You're squaring the first one. Okay? Right here, in the middle, we need to multiply the two things together. So that would be 2x. And then on the end, I need to square the 2. So I guess you could write it like this, but just know if you write it like this, you need to go a step below and actually square the 2 and square the x. And once you'll have that written down, I'm going to do a difference of cubes. So the cube root of y cubed is y, the cube root of x cubed is x, but there is no cube root of 54 and there is no cube root of 16. However, you always do need to look for a GCF first. So a GCF right here, they're both even numbers. So you can pull out a 2. So now let's see if we can take the cube roots. The cube root of 27 is 3. That means 3 times 3 times 3 is 27. The cube root of x cubed is x. The cube root of 8 is 2. The cube root of y cubed is y. So, the GCF is out front. I'm going to go ahead and write my signs down. For difference of cubes, it's minus, plus, plus. And now I write the cube roots down. Okay, and right here, I'm going to square the one that's in the front. So the 3x, I'm going to square it. 3 squared is 9. X squared is x squared. Right here, I multiply the two roots together. So that's 3x times 2y, so 6xy. And right here, I need to square the root that's on the end. So 2 squared is 4, y squared is y squared. So we know how to solve quadratics. We know the 3 formulas. I got one more thing to show you. We'll probably do 2 or 3 examples of it, and we'll be done. And the thing that I'm going to show you, it's not even a new problem. Now, so we have this trinomial right here, okay? And let's just pretend we don't know anything new. We're just going to factor it the way that we always have factored trinomials, which is multiply to get negative 81, add to get negative 18. The two numbers that do that are negative 9 and negative 9. Actually, this isn't right. Change the trinomial. Make it positive 81. I told you I'm not good at making up problems. And our answer would just be x minus 9 times x minus 9. That's the answer. Now, nothing new here, right? Find what you multiply and add to get. Find the two numbers that make those things true. And we did that. So why am I focusing on this problem? Okay? Well, what's unique, I guess, or interesting is maybe a better way to describe it, is that my factors are the same. Another way that you can describe this is x minus 9 squared. But this is the answer as well. These are both right. Okay? Whenever this happens, it's called a perfect square trinomial. Okay? Perfect square trinomials have an alternative method. that you could use to factor them, there's a formula. And I can't even remember what the formula is, to be honest with you, okay? Don't even remember it, because I don't use it. That's just another formula to memorize, and why would I do that when I already know how to factor it, okay? Now, if you want to know the formula, Alex does a wonderful job on perfect square trinomials. It does a wonderful job of showing you how to do it. Basically, a perfect square trinomial, you can take the square root of the front and the back. The square root of x squared is x. The square root of 81 is 9. And if it fits the format, then I think this is the formula. I'm not 100% sure. A squared plus 2ab plus b squared equals a plus b squared. And a squared minus 2ab plus b squared equals a minus b squared. There's two versions of it, and that looks stressful to most people. So why not just do it the way we've always done it? Okay? You can do it the way we've always done it. So this is a simple example of a perfect square trinomial. Let me do a harder example and we'll be done. Okay? Honestly, you'll probably be better off if you didn't even know that perfect square trinomial was a thing. Okay, this is a pretty rough example, okay? But I'm going to show you that we can work it the way that we know how to work trinomials. Now, the first thing, I will say this is in two variables. Just worry about your format. I need to multiply to get 324 and add to get negative 36. Okay. The one earlier today was 144 and like 24 or something. I was more familiar with 144, but 324, that's a pretty big number. So you might want to go down your list of 1 times 324 and 2 times something, okay? I don't even want to think about it. I know though, you're eventually going to get to where you start repeating. I know that 18 times 18, that's where I start repeating on this number. 18 times 18 is 324. Wonder if that's going to work. Well, in that format, it's not. Quite. If I make them both negative, they still multiply to give me that positive 324. They add to give me negative 36. So negative 18 and negative 18 work. Okay? Now, because this number out here was not 1, I need to rewrite it. I'll tell you this much, this is not on your final exam. This isn't, okay? When you rewrite those trinomials, or when you had to rewrite the trinomials, the front stays the same, the back stays the same, the middle is what changes. So instead of negative 36xy, we're going to use negative 18 and negative 18. And now that it's 4 terms, I'm going to group the front and I'm going to group the back. Okay? So 4 and 18 have a common factor of, I think, just 2. And, well, they also have an x. So take out a 2 and an x. And you got to write what you're left with. To get what you're left with, you're just dividing by the GCF, okay? So 4x squared divided by 2x. 4 divided by 2 is 2. X squared divided by x is x. Okay, negative 18xy divided by 2x is negative 9y. So just factoring by grouping is what we're doing. So I've done the front group. Let's do the back group. I bring down my minus sign. 18 and 81 have a 9 in common. 9 goes into both those numbers. X, y, and y squared, they have a y in common. So divide both by 9y. And you would get, okay, so actually by negative 9y. So negative 18xy divided by negative 9y is 2x. This is plus 81. Okay, 81 divided by negative 9 is minus 9. 81 divided by 9 is 9. Y squared divided by y is y. These two things are the same. Factor that out. If you bring out the factor that they have that's the same, you are left with 2x minus 9y. You're done. Okay, that's as bad a factoring problem as I've ever worked right there, okay? I'm just saying. Now, I guess someone came up with these formulas because you could have just said, the square root of 4x squared is 2x. The square root of 81y squared is 9y. And 2x squared times 9y times 2 is 36 xy. So since it fits the formula, you can just take your 2x and your 9y and subtract them. But why not just do the X, the bow tie that we've been doing? It's less trauma on the brain. Now, I will say, if you know the formulas, they're quicker than doing all this. But you got to do all this for a lot of other problems anyway. Why not just get perfect at it? Just get perfect at it, and you can use it for everything. Anyway, so that's anything that's new in week 7 and 8. Okay. We have that test on Monday. So on Monday we will meet in here, and then we will go to the lab. Okay. Does anyone have any questions for me? Okay. Y'all have a good day.
Do have a question for you. We do have to get our math on there.
Yes. Hey, I didn't update this class on math lab hours. Last week, we had a short week last week, did we? Your lab hours are due on. No, we were here the full week last week, right? Okay. This week, all you have to do is a half an hour. A half an hour. Okay. Sorry if I didn't already got your full hour. But yeah, since there's only 3 days this week that we're here, all you gotta do is a half an hour. Okay. Y'all have a good week.